Yeah, so this is our project created by Robo Squad, which includes me, Erica, YY, Catherine, Stephanie, Sophia, um, and we did our project. Oh, and Sarah, who couldn't be here today, but she was also a big help. So we did our project on heart disease, and we created an AI that helps in predicting whether someone has heart disease or not by looking into different parameters such as age, sex, resting blood pressure, and others. And this is a huge help because knowing if you guys have heart disease is something that can save lives. I think Erica is next.
So these are our data visualizations. So the first one we made was a heat map. Our heat map shows a correlation between the different variables that were in our data set. So when the color is dark blue, that means that the two variables have a strong correlation because the color is close to 1. So identical variables will have a strong correlation because their color is dark blue. When the color is gray, that means that the two variables have a weak correlation because the color is close to 0. So for example, resting blood pressure and fasting blood sugar don't have a strong correlation because the color is almost 0. When the color is white, that means that the two variables have a negative correlation, for example, cholesterol and fasting blood sugar. Our second data visualization was a stack bar chart. A stack bar chart is used to compare categorical data. Our graph shows a relationship between max heart rate, cholesterol, and heart disease. This graph shows that a person with a lower max heart rate is far more likely to get heart disease. So for example, a person with a max heart rate of 105 is far more likely to get heart disease than a person with a max heart rate of 180. This graph also shows that a person with a higher cholesterol level has a greater chance of getting heart disease. Our third data visualization is a bubble chart. A bubble chart is a scatter plot that has an added third dimension shown through the size of the markers. Our bubble chart shows the relationship between age, cholesterol, and heart disease. If the color is yellow, that means that the person has heart disease. If the color is blue, then the person does not have heart disease. There does not seem to be a correlation between age and cholesterol because every age group has varying cholesterol levels and a line of best fit cannot be drawn. Erica will present the last 3 graphs.
So next up is the box plot, which is comparing resting blood pressure and heart disease. It's also separated by sex. A box plot shows the distribution of a variable with its quartiles. The lower and upper quartiles are represented in the box. The median is represented by the line inside the box. As you can see, males and females that don't have heart disease and males that do have heart disease have a similar median around 130. However, females that do have heart disease have a higher median of 139. This box plot shows that resting blood pressure is not a crucial factor concerning heart disease. Each plot has a similar median, so it's hard to differentiate whether or not blood pressure will affect if a person will get heart disease. Next, we have a density contour divided by sex, and it's comparing maximum heart rate versus age. When heart disease is 1, which means that you have heart disease, you can see that the maximum heart rate is lower than when you don't have heart disease, which is when it is 0. These results confirmed our previous stack bar graph results because we said that when you have a lower maximum heart rate, you have a greater chance of getting heart disease. A density contour plot resembles a contour, but it groups a set of points that are specified by their x and y coordinates into bins. It is evident that in both graphs, people who were diagnosed with heart disease have a lower maximum heart rate than people who were not diagnosed with heart disease. However, the maximum heart rate becomes similar as the age increases despite their sex. The next one is also a density contour that compares maximum heart rate versus age, just not differentiated by sex. In the bright yellow area, at the ages 52 to 57, the maximum heart rate is 124.5, which shows that 34 people around this age have a similar maximum heart rate. That's it for data visualization. Next up is data modeling.
Oh, why?
Oh, I unmute. Sorry. So we create some data modeling. First one is our nano-based classifier. So a naive-based classifier is a data modeling method based on applying Thomas-based theorems to classify data. It predicts each category for certain data and choose the highest one as the result. Our initial result had an accuracy score of 84% and a recall score of 83%. In order to improve the result, we utilized a heat map. After that, our final accuracy score was 85 and recall score was 85. And you can see the top right and bottom left. We are trying to make this number as small as we can because they are misclassified. That means they are not true. And the second model, we choose the random forest. Random forest model are used public to public a certain outcome by splitting the data by using simple question. Katherine?
So our initial result had an accuracy score of 80% and a recall score of 89%. But when we did the grid search to improve our fusion matrix, we ended up with a accuracy score of 88.5% and a recall score of 92%. And so again, we want the top right and bottom left to be as little as possible. SVM or support vector machines. Support vector machines are supervised machine learning models that are classifying classification algorithms for 2 classification problems. So we did this. So we had our initial result had an accuracy score of 74%, and a recall score of 71%. To increase our accuracy and recall levels, we did the grid search again, and this helped us achieve higher scores of 80% accuracy and 80% recall. So now the numbers are lower.
So our conclusion, how did we make this whole website? So first we started off with the data set from Kaggle, and then we created different models using the parameters that were in the data set, such as age, sex, etc. And we chose the best ones to put on our website. And then using these models, we were able to predict if a person will or will not have a heart disease by recording the accuracy of our models. And so for some future improvements for our heart disease predictor, we could collect more data to bring light to different results. And we could also try different algorithms to improve the predictor as a whole. And we could get some deeper research to have a better understanding of the predictor to find any errors or important signs signifying if a person is likely to get a heart disease. And here's our team. And now I will show you our heart disease predictor that we made. Can you see the screen?
Yeah.
Okay. So this is the same website, but it's just a dynamic website that we made using Flask. And so down here is our predictor. We just fill it out, and for an example, I'm going to fill it out to show you guys. And then the sex, they have different drop downs that you can choose. And then now I'm going to submit it to see a result. And I don't have a heart disease. So that's the end of our presentation. Thank you for listening.